interest. So the first one says Bill invests $1,000 at 6% simple interest. So simple, we know what that means. That means I equals PRT. All right. For 1 year, how much does he have in his account at the end of the year? So we know the principal is $1,000. The interest rate is 0.06, and he's got it in there for 1 year. So if you multiply that, you're going to get 1, 2, 3. That's $60. So after 1 year, he has $60 of interest. All right. Bill invests that money. Also, how much does he have in his account? So this is just the interest plus the principal. So don't forget to do the principal plus the interest, which is $1,060. That's how much he would have in his account after 1 year. Bill invests the money he had in the account at the end of the first year at 6% simple interest, and annually for 1 more year. How much does he have in the account at the end of the second year? So now the interest rate, the principal is now the new amount. So that's your new principal amount now. So you just bring that in and you plug it in. So it's going to be 1,060. The interest rate is still 0.06 and time is still 1 year. So now we're going to use our calculators and see what that is. 1060 times 0.06 is $63.60. So $63.60. So how much does he have in his account now? Well, he's got 1060 for principal plus 63 and 60 cents. So if you add those, you're going to get 0, 6, 3, 12, $1,123.60. All right, look, the second year's earnings include interest on the first year's principal and interest. Interest that is earned on both the principal and interest is called compound interest. So this is what we call compound interest. So it's interest that's accumulated from both the principal and the interest. All right, so here's a formula. That formula is given by A equals P, and then it's going to be 1 plus 1 over N, R over N, to the N times T exponent. All right, so A is the amount after T years. P is a principal. R is the interest rate. N is the number of times you compound interest per year. Number of times interest is compoundings per year. Number of compoundings per year is a better way to say it. And T is the number of years. Time in years. All right. If interest is compounded daily, then we're just going to assume there's 360 days in a year. Weekly, that would be 52 weeks in a year. Monthly, there's 12 months in a year. Quarterly, there's 4 quarters in a year. Semi-annually, there's twice. And finally, annually, that's 1 time a year. So these are the values of N, depending on the problem. If they say daily, then you would use 360 for N. If they said weekly, you would use 52 for N, so on and so on. All right, so let's look at this next example here. So they say Kathy invested $5,600, that's your P, in a savings account with interest of 7.5 monthly, that's your N, 12, right? Determine the amount after 10 years, so that's your T. All right, so we have amount is equal to the principal, 1 plus R over N to the N times T. All right, 12 times T, N times T. So this is just plugging in numbers into the formula. Type that into your calculator. You should get I'm getting 11,827 and 56 cents. So that's the amount of money that you would have in your account after 10 years at this interest rate if they compounded interest 12 times a year. All right, compute the interest earned So for the interest, we're just going to subtract the original amount invested from the amount that we ended up getting. And that's how you get the interest earned. So 11827.56 minus the amount that you invested. That's how you find out how much interest you earned. So that's going to be 6,227 and 56 cents. 6,227 and 56 cents. All right. So let's go ahead and move on to the next example. Kathy invested $650, so that's your principal interest rate. Semi-annually, that's your N equals 2, and T is 3 years this time. So A equals P 1 plus R over N to the N times T. So 2 times 3, which is 6. All right, so that's going to be 650 parentheses 1 plus 0.08 divided by 2 close parentheses exponent of 6. I'm getting $822.46. $822.46. Compute the interest earned. Once again, you would take the final amount and subtract the amount that you invested from that, and that would tell you how much interest you earned. In this case, we've earned $172.46. All right. Perfect. Let's move on to the next one. Jean invested $6,000. P, interest rate, quarterly, that's N equals 4. 3 years later, she withdrew the full amount and used it for the down payment on the house. How much money did she put down on the house? That's 3 years. That's T is equal to 3. So A is equal to P, 1 plus R over N to the N times T years, which is 12. So 6,000, 1 plus 0.08 divided by 4 to the 12th power is 7,609.45. That's how much she put down in the down payment of her house. All right, next question. Tom needs to borrow $1,500 to expand his farm implement maintenance business. He learns that the local bank will lend him the money for 2 years, that's your T, at a rate of 10% quarterly, that's N equals 4. After hearing that of this rate, his grandfather offers to lend him the money for 2 years with simple interest rate of 7%. So how much money will Tom save by borrowing the money from his grandfather? So we have to do 2 separate problems here. Let's do the bank and compare that to the grandfather. And we'll see who has a better deal. Clearly the grandfather does, but let's see by how much. So principal, 1 plus interest, which is 10%, divided by quarterly, N, raised to the 4 times 2 years, which is 8. Over here we have the same principal, and the only difference here, it looks like, is their interest rate is 7%, and it's compounded quarterly as well, I believe. Yeah. And that's going to be 4 times 2. So let's see what's the difference in pay here. Let's see here. Oh, I'm sorry. This says simple interest. See that? Simple interest. So the grandfather has a better deal because he's just charging simple interest. He's not charging compounded interest. So principal times the interest rate times the time. All right, so let's see what that one is. 1,500 times 0.07 times 2. So you do have to be careful with the word simple. If they say simple, then you use I equals PRT. Or if they say compounded quarterly or daily or monthly, then you would have to use the other formula. So this turns out to be $210. So that means the amount that he would owe his grandfather is the original 1500 plus 210, which would be 1710. Let's see how that compares to the bank. So the bank would be 1500, 1 plus 0.1 divided by 4, close parentheses, raised to the 8th power. That's going to be 1,827.60 cents. So the way you find the interest is that, oh, actually, that's it right there. You would be comparing these two numbers. Which one looks higher? Clearly the bank. So the amount that he would save by borrowing from his grandfather would be 1,827.60 minus 1710, and that's how much he would save, which turns out to be about $117.60. $117.60 is the savings. So that's the savings. All right, if he borrows from his grandfather instead of the bank. How to find present value, what to invest for, a desired amount later. All right, so the present value, you just have to solve for P. So if you do that, this is going to become it's the same formula, you're just solving for P. All right, so let's see. Ryan will need 30,000 in 6 years. How much should he invest in a CD that has a rate of 4.72? Compounded quarterly, that's 4. So this is the amount he's going to need in 6 years. So that's your A, and T is 6. So if you want to use this formula, you can, or you can just use the first original formula that we started off with and solve for P. I'm just going to start with the original formula. Original formula was this: A equals P, 1 plus R over N, and T. See what they did? They just divided both sides by this amount, and that's how you get this formula. So I'm just going to stick to this formula because I hate memorizing more than I have to. All right, so we know that A is 30,000. P is what we're looking for. Interest rate, 0.0472. N is 4. And then that's going to be 4 times 6, which is 24. So what we're doing is we're dividing both sides of the equation by all this. And that's where this formula, so if you want to just use this formula, you can, but it's the same thing that we're doing over here. So this is what our answer should be. P equals this number divided by this big O number here. So 30,000 divided by parentheses 1 plus 0.0472 divided by 4, close parentheses, all raised to the 24th power. That looks like it's 22,638 and 57 cents. That's how much he would need to invest now, so that in 6 years, that amount becomes 30,000. All right, next problem. How much money should parents invest at birth of their child to provide their child with 50,000 at age 18? Once again, this is your amount that you want to reach. 18 is the number of years that it would take. And we got interest rate, 0.08, and N is 4. So this time I'm going to use this formula, which is the same thing as this formula. But since we're looking for P, I'm going to use this formula. So P is going to equal to A divided by 1 plus R over N to the N times T. All right, so if you enter it the way you see it, you should get 1 plus 0.08 divided by 4, whoops, the N is a 4, divided by 4, close parentheses, exponent, 4 times 18, close parentheses on the exponent, and I'm getting $12,015 and 94 cents. All right, so that's how much this family should invest now, so that in 18 years they have 50,000 for their child. All right. The village here of Kyler recently completed the construction of a new water tower. The entire cost of the water tower was $925,000 at this, and the state paid $3,700,000 of the total cost to the awarding of a grant. In addition, the village can delay paying the balance of the cost for 30 years without any payment during 30 years. To finance the balance, the village board will at this time access its 598 homeowners a one-time flat fee surcharge and invest this money in a 30-year CD paying 7.5 interest compounded monthly. Wow, that's a lot of info. So monthly means 12. What is the balance due on the water tower? All right, at this time, so let's see here. This is a lot of information. What is the balance due on the water tower? So let's see. So the entire water tower cost this much, and then the state paid this much. So if we subtract, that should be what the cost would be of the water tower. So let's do that subtraction. 925,123 minus. I'm getting 555,000. All right, so that's how much they're gonna pay. The total balance due. All right, now it says how much will the village of Kyler need to invest at this time? So that's P at this time. So we need this formula, right? 1 plus R over N to the NT. So the amount is 555,000. 1 plus the interest rate, which is 0.075, divided by N, which is 12. And then 12 times how many years? 30. All right, so let's figure out what this is. 555,123 divided by 1 plus 0.075 divided by 12, close parentheses, exponent, 160. Getting 58,907. 58,907 and 61 cents. What amount should each homeowner pay as a surcharge? Well, since there's 598 homeowners and you want them each to pay an equal amount, then that means you're going to divide that number that they owe evenly into 598. So divide by 598, and then I'm getting about $98.51. So that's how much each homeowner would pay. All right, this is more practice, so we're going to